This rather chunky device is an OxyHydrogen generator, and I've bought two of them to compare them because one is the lower output, 75 litre an hour, and this is the more upmarket, 95 litre an hour, and has a little pressure gauge and everything on it, little extra features. It's also got a slightly longer case, but just by 1.25 inches or about 35 millimetres. And these devices, you basically top them up with water and electrolyte, potassium hydroxide or sodium hydroxide, plug them in, switch them on, and they will produce gas that you can use a small blowtorch with it, but a very, very small flame. They sell it for polishing acrylic, but it's also used by jewelers for very fine brazing. So let's take the covers off these units and compare the insides of the two versions. And let's explore. So looking inside the small one first, we have a 24 volt power supply. It's actually putting out about 27.5 volts off load. And that is powering a fan at the back, which has a baffle, so half the air is spread over the power supply and half the air goes over the electrolysis chamber. The main supply comes in from the socket down here, and it goes to the switch. Then it goes from the switch to the power supply, but also one leg is broken via a pressure switch here, which cuts the unit off by just killing the main supply to this switch from the power supply when the gas pressure reaches an appropriate level. There's a little current meter in the front here, and that has its own little connector here on the power supply. Does the other one have the same arrangement? Yes, it does. By the look of it, it does. There are differences between the power supply of the small one and the bigger one. The bigger one has two fan connectors, a little heat sink on this component down here, which may be a regulator for the fan. But other than that, they look very similar. The fan in the other one is much bigger though. So if we take a look at the other side of this, we have the electrolysis chamber. And interestingly, the chambers in both the big unit and the small unit are physically the same size, but I don't know if the electrolysis cell inside is the same size. Maybe I'll grind one of these open and we can take a look inside it. I have found a video though on YouTube that shows what's inside, so it might be easier just to link to that one, but we'll see what happens. But the idea is that you put electrolyte into this, either sodium hydroxide or potassium hydroxide, which is apparently preferred. It was very hard getting potassium hydroxide, but I have got some. And you mix it with water, 150 grams of potassium hydroxide to about a litre of water, and you pour it in through the top here to fill this tank. It then has DC applied across it, and it creates the gas. That comes from the top manifold here, and there's a loop of pipe that is used as a liquid level gauge, and there's the outlet pipe here which goes to this cylinder. Now this cylinder here is the anti-flashback cylinder, hopefully, and it's got a little dip tube to the bottom, and you fill this with either water or alcohol. The alcohol can apparently enhance the flame in ways. You can also apparently add boric acid to it to make the flame more visible. And the liquid then has to bubble through this, and they say this should be about a third full. I think there's a balancing act between accidentally pulling liquid back into this. I'm not really sure, because as this cools down, it will create sort of negative pressure if it's not, if the gas has all been used. It's a complex thing to actually use properly. This also has a little pressure release valve and safety valve on top, and here's the output that goes through a bit of plastic tubing. This plastic tubing to the gas torch, which looks like this. It's a very, very small gas torch. So let's take a look at the full size one now. So I shall put this out the way. Exhibit B. Note the big, chunky, much louder fan. A very similar power supply, but with those little features. It's got a heat sink on that component, which may be feeding both the fans. Other than that, it looks pretty similar. There is no marking on this power supply as to a rating. I can see a little manufacturing label inside, but there's nothing really obvious on the outside. So it's the same arrangement. It's the mains in being interrupted via the pressure switch, that cuts it off when the gas pressure reaches the appropriate level. On the other side, as you can see, it is just a very similar arrangement. It's the same size of canister. There's the other half of that fan poking through that baffle so that it spreads the air across both sides. And there are vent holes in the bottom of this to let the air out. This one has, internally, it's got a little pressure release valve, possibly a safety feature to prevent an overpressurization feature, although blowing OxyHydrogen out isn't a great thing. And this one also has the anti-blowback flashback thing with a pressure gauge on top, graduated from 0 to 50 psi, or 4 cubic feet a centimeter squared. Right. Okay, right, tell you what then, I'm going to get the big one and maybe do this to both of them. But I'm going to put the electrolyte in at least one of them, and then we can actually test this and see what it looks like. One moment, please. Okay, progress so far. I started off by making a batch of the potassium hydroxide for this unit. And when I was using it, I took some current and voltage readings. The voltage stays fairly constant. The current was 11.7 amps on the big unit and 9.5 amps in the small unit. Now, I had an issue with foaming up in here, that when I released the pressure from the little gas torch, and I'll show you the gas torch in a moment, I was getting liquid blowing through here and into the bubbler at the side, the little sort of like the anti-flashback and, well, alcohol addition type thing that they use for various liquids. And I wondered if that's just because this was a more vigorous unit. So the other unit, I put the sodium hydroxide, that's just standard drain cleaner, lye, caustic soda. I made a batch of that, and the smaller unit must have something different, because same voltage, I was getting 9.5 amps. Incidentally, the 11.7 amps are showing 15 amps on the display here, and the other unit, 9.5 amps, was closer to 10 amp rating. So I shall turn this on. I should say that I purged this. I emptied it out of the potassium hydroxide, and I refilled it with a new batch of the sodium hydroxide, which is I had that all along. I wish I'd known this in the first place. And it didn't foam up and bubble, so it's not been blowing the liquid through the pipe. So let's move this to the side, right? And I'll turn it on and there will be noise. Making sure I've got all these caps on nice and tight. And then I'll probably have to focus down onto this, but I may have to change the lighting anyway. Let's try it with the existing lighting. I'll just pause focus down. So here we go, I'm going to light it now. First mistake I made lighting it was, oh, incidentally, it cuts off at 18 pounds a square inch. But the first attempt I had at lighting, I just opened it up full throttle. That's not what you do, because it does blow itself out. Hear it bubbling? Can you see that? You can see that flame. Now I can change the lighting here. I can take the exposure off. I can turn this light off, so you can actually see the flame. I can zoom down it a little bit, or I could bring it up to here and focus onto here. Oh, it's hunting for the focus. It's not getting the focus, is it? It's hunting. Oh, hold on, I'll get it to focus. It is focused. So with this flame, ow, that at considerable distance, that's a very, very hot flame. And if I turn this up, I've not had a flashback yet. If you see a flashback, you'll see it as a yellow flash through the hose. Not too comfortable at doing that. Not had one yet. Turn it up really high. Big flame, quite a big flame for this, even though it is just a sort of micro brazing. You can turn it down quite low as well. But this flame, as an example, well, let me set up an example. I'll just turn it off at the moment. Slight pop as it goes out. And I'll just be back in a moment. So while the flame is running, the pressure does drop down, but watch, this is glass. Watch how fast it comes up to temperature here. It actually is very prone to cracking the glass, and because this glass is just very susceptible to, it's not got the tolerance, the thermal, What's the best way to describe that? But you can see it is melting the glass. Thermal coefficient of expansion of the borosilicate, that's just basically tapered down to that, and the whole glass rod is glowing at the moment. I shall just basically pop that into the flame every so often. I wonder if this is uses in glasswork. I don't think it would be good for the large area things, but it's certainly done a good job of that. I need to get myself some borosilicate glass and try that out. This is it using the larger diameter nozzle, by the way. Incidentally, what am I going to do with this now? I shall put it on the edge of my bench like that, and I shall turn this off. Oh no, I won't turn it off. Yes, I will turn it off. I want to do a little experiment. I will get some, hold on, just go and grab it. Some whiffle juice. Pop some whiffle juice in here. That's just basically a detergent and water. And I've been warned this might be quite loud. So let's let some gas under it. Bubbles. Just some bubbles. And then light it. This might be loud. Fucking hell. The ears are ringing. Yes, I was warned. I still did it. Right, okay, this is why we're not going to have OxyHydrogen whiffles. Oh, that was so loud. God, such a small quantity as well. Or was it just, no, because the hydrogen would rise. But you can inflate balloons with this and they will float. That makes for the idea of making huge exploding balloons. I was taken by surprise by the volume of that. My apologies if your speakers are now dead. That was just, I think my ears are now dead. They're literally whistling. Just like everybody who I saw did this experiment already on YouTube was surprised. And I thought, no, it can't be that loud. Yes, it is. So that's almost worth getting it for, really. But anyway, let's go back to the workbench, the normal workbench, and do a summary of this. And in the future, I may actually open one of these. I may open one of the chambers, but we can take a look right now because I know what's inside, and we can take a look at the technology. One moment, please. Okay, now we're back at the bench. Let's talk about what's inside this unit. And from what I've seen online, I really do want to cut one of these open to see for myself. It contains a plastic housing with vents to allow the electrolyte to get in and the gas to get out, because keep in mind this is literally just splitting apart water into its separate molecules of hydrogen and oxygen. But it appears that, as opposed to many approaches to this where they link every second plate, in this case, because they're using a higher voltage, they've got one plate at either side, and this is just rectangular plates, and they've effectively got 12 plates in all, but only 2 connections, one to each end, and the rest are forming almost like a battery of electrolytic cells. So in normal operation, the 24 volts is applied across that. The electrolyte is a mixture of water and either the potassium hydroxide or the sodium hydroxide. In the instructions, it does say sodium hydroxide. Lots of people saying potassium hydroxide is better. I don't know why mine was foaming up and going through the pipe and basically contaminating the bubbler. But it's possible, just possible, that were oily deposits in the container I mixed it in. And because potassium hydroxide is used in soap making, as is sodium hydroxide, it actually emulsifies and forms a soap out of oil. So it's possibly contaminated. The only way to find out is to purge that system again and then refill it with another batch of fresh batch of potassium hydroxide made in the same container which I made all the other ones in, which was the same one, but could have stripped all the grease out of it with the first batch if that was the problem. However, you mix it in with the water, but once that's done, they recommend, depending on usage, they recommend sort of emptying it out and replenishing it every so often just to get a clean batch in with no contaminants. But all you have to do normally is just top the water level up, and there is that little fill tube. Effectively, it's a little tube that comes out and goes back in, and it gives you a window of the height, and it's got levels that they say this is what it could go up to. But when you fill it up initially, there is a little mark or a gap in the mark which shows the level it goes to, that 1 litre, because it doesn't submerge the plates fully. And they say when it goes down to this level, top it up just with ordinary water. You basically relieve the pressure in the system, take the top off and just add plain water because the electrolyte will still be in there. It's just the water that's been split out and has gone out. The pressure switch, which turns the power supply off, was set at £18 a square inch, but during operation, I should zoom down this, shouldn't I? One moment. That's better. So during operation, that pressure dropped. It depended on how high you had the nozzle set and the orifice at the end of the nozzle, and it's really odd. They do seem to have different orifice sizes, but none of them are marked as to what they are. You literally have to either experiment or take a look at a bright source and hopefully see the light shining through the end of that, and the more light comes through, the bigger the orifice, so to speak. But certainly with the larger orifice on the bigger unit, because there is a variation, the big unit, it's 24 volts supplied across that, and it was about 11.5 amps, which equates to 276 watts. And I'll bring the kink calculator in for this. The other unit was 9.5 amps. So that was 24 volts times 9.5 gives roughly 230 watts, say, versus 280, so about 50 watts of a difference. It certainly seemed to produce less gas. It took much longer to cut out in the pressure switch, but I couldn't see the pressure rising because there's no gauge on the cheaper unit. It's almost like the slightly more expensive unit comes with all the extra features, and that's its main selling point. A little bit more gas, a little bit more out, a bigger fan, cooling fan, and for maybe heavier, longer-term duty, and also just the pressure gauges and other bells and whistles, and more nozzle tips. You get the same gun, but you got an extra 1 or 2 nozzle tips included. So there's a bubbler, and they say you can fill it with water or alcohol. I was like, do I really want to fill this with alcohol? Because one of the problems with HHO, the OxyHydrogen, is that it's not separate. It's not like an oxyacetylene torch or an oxypropane torch where you've got an oxygen line and you've got a gas line, and then they're combined just as they go out. In the case of the OxyHydrogen system, it's all combined. So this gas in here is totally 100% explosive. The gas in here is totally 100% explosive, and you can get flashbacks travelling down the line and into that. But it's interesting to know there is an initial explosion, but then it pulls a vacuum because it is converting those gas molecules of hydrogen and oxygen back into liquid form, and that's much lower volume. So technically speaking, if there was an explosion here, it would then suck all the liquid from here back into there. But it wouldn't be a massive mega explosion, hopefully. But it's worth making sure this is kept topped up. The other thing is that people say if they use the alcohol in it, and you can put a bit of boric acid in, it makes the flame green. I didn't get the green flame. But they did say use methanol. I used methylated spirits, which is ethanol, and isopropanol, I think. But that will have an effect on the flame. Theoretically, boric acid is also going to have a slight fluxing effect. I know that at Hussman with the oxyacetylene torches, they had a bubbler that produced an intense green flame, and it may actually have been boric acid it was going through and methanol for the flux effect. So here's the little torch. To assemble it, you unscrew this. It's just a hollow tube. I thought this was going to be the flashback arrestor. You unscrew this, you shove the pipe up this, you put this over the pipe, you press it over this little anchor here, and then when you screw it on, it wedges it over tightly over that, and then you slide this up and over that just for the pretty handheld look. And this just does look like an ordinary valve. It's not got flashback stuff. It's worth mentioning that some of the other manufacturers of these for jewellery use supply what looks suspiciously like a syringe with syringe needles on it. Well, they are syringe needles. Those are the burner orifices. I suppose it makes sense. One of the other YouTubers who was making one made a big thing about packing this stainless steel wadding or brass wadding that you can get for scouring dishes and things like that, stuffing it in there, and they said, this is the flashback arrestor. Then he powered it up, lit it, and the free flame came out, and then it just went whoomp right back through it. It did not help. So theoretically, if it does flash back into that, it's not going to be an earth-shattering explosion. There may be a brief blip of high pressure, but then the vacuum. Certainly it's loud, I can tell you that. Now, other things. These are sold. Is this just a reason to sell them, that they're making I know they are used for this, for acrylic polishing, where you get a piece of acrylic and you've got a ragged edge on it that you've cut with a laser the laser is usually pretty clean, or you could have just basically used a saw to cut it. And then you can take the flame and just lick it along the edge, and all the roughness picks up the heat and first, and it basically melts it, and it just creates a perfect shiny edge. But there is an art to doing it. But the other things it's sold for are jewellery welding, and that's a real thing. One of my friends teaches jewellery making, and he says they use these things, somewhat more expensive, jewellers' ones, but pretty much the same thing. And they produce that tiny flame that is perfect for brazing tiny little objects. But the other things they're sold for is reducing carbon from cars, and this is quackery. There are people who have tested them and said it did nothing. And they're basically a big, huge box with not much in it. Pretty much what was in the unit you saw, but minus the power supply. It just runs straight from the car battery. And they just stick it in the air intake, and it removes all the carbon by making it run at a higher temperature. They said it did nothing. The other thing, and this is scary as heck, because the quack industry is, all about, breathing this is good for you, breathing that's good for you, they sell kits that you can actually just stick it up your nose and breathe in OxyHydrogen. And the hydrogen's good for you. It does something. It probably removes oxygen from your body and de-ages you or something like that. I'm not sure what they claim. But they say, oh, it's okay, it's not going to explode in your lungs. Well, would you do it? Would you actually breathe an explosive gas and oxygen mix into your lungs? I'll let you decide that. And the other thing, and this was tested quite extensively by Project Farm, some claim that if you inject OxyHydrogen generated by the car battery into your vehicle, the air intake, it increases fuel efficiency and gives your vehicle more performance. He showed it did not. He tested it with a fixed acceleration, how long it took with and without the OxyHydrogen being injected, and it was the same. You can go and check his videos out. They're very good. But the other one was he had a generator with a measured portion of fuel, and with and without the OxyHydrogen, it was within seconds, nothing. If anything, it was slightly less efficient because the air intake was being imbalanced. So that's all quackery. And this is where these people saying, oh, I run my vehicle on nothing but water. Strangely enough, there's not many water-powered cars. Oh, yes, but big oil did the conspiracy thing, and, they defeated it, they bought the patents. No, they didn't. Then the guy died. That always helps the conspiracies. In reality, the ones that show a vehicle running badly on OxyHydrogen being generated are using much more power to generate the oxygen hydrogen from the battery. It's basically the vehicle's running on the battery with very low efficiency. So it's all a bit of a scam. But now I've said that, all the conspiracists come out and be abusive in the comments. Well, that's fine. I'm used to it. But there we have it. It's not the last video about these things. I reckon I'm going to open the electrolysis chamber on one and get the angle grinder into it and just chop it open, and then we can get a closer look at that. But that is it for now. It was probably one of the loudest videos I've made, the one that left my ears really ringing. I hope that wasn't too bad earlier on. But they're very interesting machines, and if you choose to get one for any reason, do know that there are certain hazards associated with them, but they're available there for your purchase on eBay or AliExpress. It was cheaper on eBay I think maybe they're just getting rid of them, I'm not sure. But or just bulk shipped in advance so that they can just distribute them from the usual warehouses. But they are available from local warehouses depending on your country's tightness on regulations. But there we have it, the OxyHydrogen flame generator, electricity to flame.